Alright, so in Chapter 7, Section 5, we're asked to sketch a graph. So it looks very linear, except it has an inequality. So y is greater than 5x minus 4. I want to make a line on this thing. I know that it has a y-intercept of -4. And if I plotted points or whatever, I could go up 5 over 1. And I would see that it looked similar to this. Now I need it to be a dashed line because it's a greater than 5x minus 4. So that's something that I know. And so I need to make it that dotted line. But I also need to fill it. Where is it greater than? Are the values over here make it greater than 5x minus 4 or over here? And the way that you can do that is just check. Check a point that's obviously on one side to see if it's true or not. I always like to try to pick a 0, 0. So if I plug 0 is greater than -4, is that true or false? Well, that is true. So I'm going to shade in this side. And that would be my solution. So you graph your equation and then you shade in the appropriate side. If it would have been a greater than or equal to, then I would have had to have a solid line and then shade it in. Another one is like number 2. So if we were looking at this equation, it just looks like a good old x squared. But so I'd get an equation and it would maybe look like a y is equal to x squared minus 1. And that's what it kind of appears to me that it would be. But it's not an equals to because I have a shaded region. That means I have an inequality. So is it greater than or less than? And these are hard for me to tell sometimes. If I put, I kind of think that it's a greater than. Reason why is that it's above itself. It's above the line. But I'm going to check that to make sure. So I see a point 0, 0, and I'm going to see if it's true. Is 0 greater than, if I plug in a 0 here, I get -1. Is 0 greater than -1? And that's true. So this would be the part that would be shaded. One more thing looking at this, is this a dotted line or a solid line? It's a solid line. So after you hit the greater than symbol, right, if you hit greater than, just hit equals to as well, and it'll put the line underneath. So that's what this would look like for me. And then one more. So sketch the graph of these, and so you have a couple things that are a couple equations that you're looking at. So what I'm going to do is I'm going to graph these in Desmos. So let's move that back over. And if I graph these two equations, Desmos does a great job of doing the inequalities and letting you see what's going on. So x minus 5y is less than -15. And so it'll do the shading for you. I could do another equation, 7x minus 4y is greater than -12. So the part that I'm interested in, if I look at the graph, is I'm looking at the intersection. So I have, if I'm solving systems of equations, so I have two equations, I'm looking for the overlap, which looks to be in this area right here. That means any point within here is going to solve both equations. And so that's what we're looking for. A point that will solve both equations. And since I have inequalities, this is the region that would do that. So if I pick a point out, 2015. So if I look at that point, 2015, right? It should solve both of these equations. So let's check it. 20 minus 5 times 15, what is that? So we could check it out. 20 minus 5 times 15, whoops, times 15. That's -55. Is -55 less than -15? And the answer is yes, because it's to the left of it, so it's less than. We could plug in that same point 2015. 7 times 20 minus 4 times 15, and I get 80. Is 80 greater than negative 12? Well, it's greater than negative 12 as well. It solved both of these inequalities. So any of the points in this region would make both of these true. Also note that I have dotted lines here, so the points on the lines would not solve both of the equations.